All right. So when we have a complete the square that has an a value, we have to do an extra step. So we can't just go straight into taking that middle term and splitting it equally. Oops, I'm gonna, there we go, block it out here. We're still gonna look at the, hang tight guys. What's up? We're still gonna start with the just these pieces, but before I can put it into the box, I need to factor out that a value. We're gonna have that -2 be out in front as an a value. And then we can do this. So if I factor -2 out, it gives me x squared. And if I factor -2 out of the middle piece, we get -5x. That -5 is still just kind of sitting over here. He's just chilling. He's not doing anything. And he's really in the way right now, so we're just going to ignore him for now. He's still chilling. He's just going to hang over here. When we're looking to complete the square, this is the piece we're going to put into our box. This is the one that we're going to split equally to find our perfect square. So our x squared is going to go here. And how can I split -5x equally between the two pieces? What's up? 2.5. We're going to have -2.5x in each of them. Which means what's going to go here? What's going to go right here? Say it again. Not -5. Because what are our factors going to be when I pull pieces out? If I pull a factor out here, it's going to be an x. And when, yeah. Because we know our factors are going to be, whoa, that's not the pen. X and -2.5 and x and -2.5, that's an x. So I know that this bottom right piece is going to be 6.25. 2.5 squared. 2.5 times 2.5. I said a whole bunch of pieces at the same time. So we have our y equals our -2. All those pieces are becoming our x minus 2.5 squared. Our -5 is still chilling over here. But we added in 6.25 inside this piece. So I can't just willy-nilly add it to one side. I've got to add it to the other. It's also not by itself here. This is -2 times this whole hot business, right? -2 times this whole thing. So if I'm adding 6.25 in here, I have to also multiply it by this guy. So when we add it to our other side of the equal sign, which I'm going to scooch my y. I'm not doing that. Ha, got it. So I'm going to scooch my y a little bit closer. So we're going to take our a, whatever that is, that -2, times our, whatever we added in, 6.25. And that's what we've added over here with the y. That looks like a hot mess of crazy. But it's okay. It gets the point across. So what we really have over here is -12.5 plus y equals this. A whole lot of pieces here. Everyone see where the 6.25 comes from and then where the 12.5 comes from. Because this is the biggest piece for today. And I know I have it super duper tiny right here. But this is the big piece for today. Okay. Because then our last piece here is I like y by itself. What can I do to get y by itself? Add 12.5. Exactly right. we're going to have y equals negative 2 x minus 2.5 squared. And if we add 12.5 and we add 12.5, we get 8.5? Yeah. No, 7.5. Yeah, 7.5, sorry. It's early. Brain not braining. So we can complete the squares even if our a value is not 1. What would our vertex be here? Our vertex is going to be the point what? 2.5. Yep. My handwriting is trash today. What is going on? Slightly less trash, but it's just trash. Okay, so when we're asked to find our vertex, completing the square is always an option. For the most part, most of the equations I ask you to do will be factorable, and you can do it either the splitting, finding the in-between on your roots, or you can complete the square. There is one on the review that I did not check well, and it does not actually factor. So you would have to complete the square. Okay, so for the most part, everything else we see will be factorable. So you can do it either way. But I wanted us to see this. Okay, questions on this first one. So we're going to do number 8, and then I'll let you guys fill in the table, and then we're done for the before spring break chapter. We're going to do number 8, and it's at the very, very bottom because I didn't want to reprint my square. So I'm just going to rewrite my equation. So we have our y equals negative 3x squared minus 5x. Ew, this one's so gross. I hate this one so much, but we're going to do it. This one's so gross. All right, I'm just moving the equation up just so we can see it. This one's number 8. I just switched our r of x to be a y because r of x is just y in a coat with a mustache. He's just dressed up all fancy and in disguise. It means the same dang thing. So when we're looking to complete this square, first thing we got to do is we got to say, all right, I want to just look at these guys, and I need that a to go outside. So that negative 3 is going to come out, and I want just x squared here. Because always, whenever we're in vertex form, it's just an x squared here. There's nothing inside, no negative, no number, no nothing. I need that x squared by itself. Then we've got to figure out what our b term is. What is this guy going to be when I divide by 3? Or divide by negative 3? Yeah, it's going to be 5/3, which is gross. So we can add, and it's going to be negative 5 divided by negative 3, so we get positive 5/3 x. I'm going to leave it as a fraction for now because it's slightly less gross. For the most part, the only time we're going to have to do completing the square is if it's not factorable, which unfortunately means a lot of those times we're going to wind up with fractions in gross places. Like that. No. Ew. Okay, so that is the piece we are now ready to split it into the box. So I'm going to use my box. I do have my box way down at the bottom. So we're going to take our x squared goes into the box. How can I split 5/3 into 2 even boxes? How can I cut 5/3 in half? What's half of a third? Close. Yeah. See how we could get there? All right, so let's see. If I do 5/3 divided by 2, that's also 5/3 times 1/2. Or you can think about 1/3 if I take my pi thirds. How many pieces do I get if I cut my thirds in half? Either way, when we multiply the fractions, we get 5/6. Or if you think about 1/3 piece being cut in half, it's 1/6 of a piece. Yeah, we're gonna be 5/6. It's gross, but that's a thing. So 5/6 x, 5/6 x. Especially when you wind up in the thirds family, thirds, sixths, ninths, those kind of things, fraction-wise. I do recommend keeping them as fractions instead of decimals, since they are a non-ending decimal. Like, they just go on and on forever. So I do recommend keeping them as fractions. I don't know that I would be so petty as to count it wrong, because you're doing the thing. And honestly, doing these as decimals is probably harder. So this tells us we know what our factors are going to be. I know I want an x here, and I'm going to want a 5/6 here. And I want an x here, and a 5/6 here. Does anyone know what this piece is going to be? What over 36? Not 10. 25 over 36. 5 squared is 25 over 6 squared, which is 36. Exactly right. So then we have to be careful when we're putting this into our factored form here, because I'm just willy-nilly adding in a 25 over 36. So for my equation, I have to also add in that same piece over here, but we can't forget it's inside here. So we're really going to have y plus -3 times our 25 over 36 equals -3 x plus 5/6 squared. I know I'm going all tilty, but I'm trying to avoid all my other things. Plus 2. There's a lot of pieces here, and it's kind of nasty. I'll scooch to the side so we're not doing that funky job thing again. And we're going to simplify pieces as much as we can. So, let me get another color. This, we can type into a dang calculator. -3 times 25 over 36 is going to give us y minus 25 over 18? No. 12. There it is. Yeah, that fits better. And this still equals all this hot mess on the other side. -3 times x plus 5/6 squared plus 2, and oh my gosh, we're almost done with that. What can I do? I want y by itself now. Add that to both sides. Exactly right. We're going to add nasty. 25/12. Especially when we have funky fractions like this, use a calculator. 2 plus 25 fraction bar 12. Because we're going to get y equals -3 x plus 5 over 6 squared should be plus 4 into 12, or 49/12, depending on how the thing simplifies it. Yeah. I'm going to put 4 into 12 because that's easier. And that's our completed square form. That's so gross. That is so gross. Like, our vertex, what is our vertex? The point is, what's our x? Just like this, 5, 6. Watch your sign. Negative 5, 6. What's our y value? 4 and the 12th, or 49/12. 4 and 1/12. I put it as a mixed number here simply because if we were to graph this, 4 and the 12th is way easier to say it's 4 there-ish than to say 49/12. Sure, I can totally tell you where that is off the top of my head. The only reason I have it as a mixed number. I genuinely do not care. Okay, if you know how to, if you want to work with the improper fractions, I'm down. Go for it. Work with the improper fractions. It makes zero difference to me. Okay, so completing the square is going to happen more frequently when we have gross equations like this. These guys aren't factorable. Even if they were, finding our in-between being negative 5, 6 is ew. Or our vertex of 4 and 1/12. Ew. So completing the square takes the ew and actually makes it less gross. Because if we did this as factors and finding our split the middle, that would be really bad. Like, it's not pleasant either way. But to be fair, we're not going to have tons of these. Okay? So for the rest of today, when we were on page 86, when we did this table, I told you could do all of this and all of this. I said we didn't need to work too hard on these guys because we hadn't learned them yet. Now you have. So you should hopefully have the standard form for this guy, which will give you your vertex, which you can then complete the square and find your vertex. And this guy, it's going to be unpleasant, but it's definitely doable to get your vertex form here. Okay? The whole rest of today is filling in these two spots. Ask questions. Use, like, let me help you. I'm happy to help. If you didn't get the rest of this table filled in, now's a great time to do it. It is a super duper awesome review in preparation for doing the review. Okay? So use the rest of this time to finish out these two spots if you don't have them already. Okay? And then after that, it's review for the quiz. This is our last bit. Okay? Because quiz is Wednesday. Wednesday's quiz is Wednesday. All right, so work on that. Let me know if you have questions. I'm absolutely thrilled to help you guys through it.